Hello guys. Welcome to Academic World by Mpatala TL. And obviously for sure, you know what we do here. We do maths. So in this topic, actually here I'm taking mathematics grade 10. So if you are doing grade 10, this should benefit you. We are going to look at algebraic expression and exponent. And guys, let me emphasize this one. When it comes to the topic of algebra in maths, algebra is very important. Algebra is a building block of your understanding of maths. If you get algebra very well, believe you me, your maths is going to be good. So it's very important for you to understand this topic of algebraic expression and exponent. You will need these skills of algebra in higher grades, in grade 11, in grade 12. You will need the skill of algebra even at varsity and college level. Very important concept of maths. So let's go through it without wasting time. Algebraic expression and exponent. So I'm going to give you certain skills and certain ideas that you need when you're working with algebra. So let me take you through this content. The first thing that I want us to look at is multiplying a binomial by a trinomial. So already there are two key words: binomial, trinomial. Multiplying a binomial by a trinomial. That's the first thing that I want to teach you. How do we multiply a binomial with a trinomial? And what is a binomial? What is a trinomial? Remember, I'm saying we're going to multiply two guys. We're going to multiply a binomial with a trinomial. What is this binomial and what is this trinomial? So let us look. What is a binomial? A binomial, we are talking about the expression with two terms. With two terms. Once you have a mathematical expression with two terms, we can consider that as a binomial. Let me give an example of a binomial. I will say 2x plus 4. So this expression, 2x plus 4, has got two terms. 2x is your first term, 4 is the second term. So we call 2x plus 4 a binomial because it's an expression with two terms. What is a trinomial? A trinomial is an expression with three terms. So for sure you know that the word tri has got to do with three. Triangle meaning three angles. Trinomial, so it's an expression with three terms. Let me give you an example of a trinomial. You can think of 3x squared plus 6x plus 5. So this is a trinomial. How many terms does it have? 3. What is your first term? 3x squared. What is your second term? 6x. What is your third term? 5. So this 3x squared plus 6x plus 5, it is called a trinomial. So this is what we are going to be looking at. How do we multiply a binomial, which is called an expression with two terms, with a trinomial, which is called an expression with three terms? So we need to know how to multiply these two. Bear with me while I'm erasing here. Now, okay, I will explain here. They say the key strategy. What are the strategies that we are going to use when we multiply a binomial with a trinomial? So they say multiply each term in the first bracket by each term in the second bracket. And then the second strategy will be to add like terms. I'm going to show you this mathematically because maths can be understood with practice. So we have to work these things out so that you understand. I will explain these two strategies I've talked about. I'm going to give you the first example. Yes. So we have a binomial here. Oops, I was here. We have a binomial here. Here we have a binomial. Here we have a trinomial. So I'm multiplying a binomial with a trinomial. The question is, how do I do this? I said multiply each term. This is my first strategy now. Multiply each term in the first bracket by each term in the second bracket. So if you look at my first bracket, which is a binomial, in my first bracket I have a binomial. And in my second bracket, I have a trinomial. So I'm saying take each term in the first bracket. The first term in the first bracket is 2a. So I'm going to take 2a and multiply it by everything in the second bracket. So that is why I wrote 2a here. You can see I wrote 2a. Then I'm saying this 2a, I'm going to multiply it with every term in the second bracket. Remember, this comes from your second bracket. This a squared minus 3ab minus b squared comes from the second bracket. And 2a come from the first bracket. So you take, let me say, I took the first term in the first bracket. The first term in my first bracket is 2a. I'm multiplying it with every term in the second bracket. So I'm going to apply the same strategy to minus 3b, which is my second term in the first bracket. The first bracket is made up of two terms, which is 2a is your first term. The second term is negative 3b. So I'm saying I'm also going to take negative 3b and multiply it with everything in the second bracket. So here it's minus 3b. I'm going to multiply it with everything in the second bracket. This comes from the second bracket. So you can see it is 2a. I'm writing it here. It is minus 3b. I'm writing it here. So I'm saying 2a will be multiplied with everything in the second bracket. Minus 3b will be multiplied with everything in the second bracket. So if you understand this procedure, what I've done here, then multiplying a binomial with a trinomial, it should be easy. Let's continue and see what happens. Let me erase here. Okay, let's see what happens here. Yes. Yes. So let's go through it step by step. I said 2a times a squared. I'm using a law which is called a distributive law. Then this number outside the brackets, 2a, should multiply every term in the bracket. So I'm saying 2a times a squared. It means I'm distributing 2a. The procedure I'm following here, it is called the distributive law. 2a times a squared. So what is 2a times a squared? Okay, I'm going to multiply numbers together. So it is 2 times, there is invisible number here. There is invisible 1, which we normally don't write. So I'm going to say 2 times 1, which is 2. Now what is a times a squared? A times a squared is going to be a cube. For now, I'm not explaining why a times a squared is a cube, but I don't think it's hard for you to get the idea that a times a squared is a cube. But I'm going to explain this when I'm looking at law of exponent as we continue. So for now, I'm saying a times a squared is a cube, which makes 2a times a squared 2a cube. So yes, you can see 2a, which is outside the bracket, multiplied a squared to get 2a cube. Now I'm going to multiply 2a again with minus 3ab. I'm distributing this 2a. That is why we call it distributive law. So I'm saying 2a times negative 3ab. What is 2a times negative 3ab? Let me write here 2a times negative 3ab. You know that 2 times 3, 2 times negative 3, it's a negative 6. A positive number times a negative number is a negative. So 2 times negative 3 is a negative 6. A times a, it's a squared. You have this b. So 2a times negative 3ab is a negative 6a squared b, which is this one. We continue with the same idea. The number outside the bracket should multiply every guy inside the bracket. Distributive law. So now we're going to say 2a times negative b squared. What is 2a times negative b squared? 2a, which is positive, is being multiplied with negative b squared. So the answer is going to be negative. 2a times negative b squared. How much is 2a times negative b squared? So it's going to be negative 2a b squared, which is this one here. Okay, hopefully you guys, you are following. We are continuing with the topic of maths algebraic expression for grade 10. So now I'm going to multiply negative 3b by every term in the bracket. So I'm going to this part now. I'm going to say minus 3b times a squared, which is going to be minus 3a squared b. Or you can even say it's minus 3b a squared. It's a matter of preference here. Let me explain this. It's minus 3b times a squared. You can say it is minus 3b a squared, or you can say it's minus 3a squared b. So I picked this one. I said minus 3a squared b. It means in this, if you look at my expression, I prefer to write variable a first. So it's a matter of preference. So it becomes minus 3b times a squared is minus 3a squared b. So I'm going to multiply negative 3b with minus 3ab. Remember, the number outside the bracket, multiply every term inside the bracket. So now I'm going to multiply minus 3b with minus 3ab. Minus 3b with minus 3ab. Minus 3b with minus 3ab. Let's go through that. Minus 3b is going to be multiplied with minus 3ab. We know that negative times negative is positive. So when I multiply negative with negative, my answer is positive. So the result is going to be positive. Actually, negative 3 times negative 3 is positive 9. So it's 9a, this a here, and b times b is b squared. So it's 9ab squared, which is here. So lastly, I'm going to multiply minus 3b. Sorry, I need a pen. I'm going to multiply negative 3b with negative b squared. The one outside the bracket, multiply every term inside. So it's minus 3b times minus b squared. We know that negative times negative, it's positive. So I'm going to have 3 b times b squared, it's b cubed. So it's 3b cubed, which is this one. So yeah, I think we are getting there. We are finishing on working with this multiplication of a binomial and a trinomial. How do we multiply a binomial and a trinomial? I said you just take the number from the first bracket and multiply it with every guy in the second bracket. Take the second number and multiply it with every guy in the second bracket. Then from here, after multiplication, you are going to go and look at one of the important skills in maths. The skill that I'm going to use here, it is very, very important, which is called adding of like terms. When you have an expression like this one here, from 2a cubed, which is how many terms now? It is 1, 2, 3, 4, 5, 6. This is an expression with 6 terms, and you have to start looking for the like terms. And what are you going to do to the like terms? You add. You can add or subtract like terms. In maths, when we add, we can only add like terms. When we subtract, we can only subtract like terms. Actually, what I'm explaining here, provide the information why we cannot add x with y. X plus y cannot be added. They are not like terms. So we'll add for like terms. But if it's x plus 3x, you can add this 2 guy and claim that it is 4x, because these 2 terms, x and 3x, are the like terms. So in this expression here, we have to look for the like terms and add or subtract those like terms. So my first term is 2a cubed. So I'm going to look for the term with variable a of an exponent 3. This is a of exponent 3. Do I have a term with a of exponent 3? No. On my second term, it's a to the exponent 2. Actually, it also has b. This one is a to the exponent 3. It's alone, no b next to it. So this cannot be the like term. So actually, 2a cubed cannot be added to any other term. It doesn't have a like term in this expression. Let's go to the second term, which is minus 6a squared b. Minus 6a squared b. Does it have a like term? Minus 6a squared b. Look for the like term of minus 6a squared b. Does it have a like term? We are going to look for a of the exponent 2. And I see it on term number 4, a of exponent 2. And this a of exponent 2 is with b. It's minus 6 a of the exponent 2 b minus 6a squared b. So even here I have minus 3a squared b. So second term and fourth term, they are the like terms. They have the, okay? But you can tell it's a squared b minus 6a squared b minus 3a squared b. So we can add these two actual. Minus 6a squared b minus 3a squared b is going to be minus 9. I've realized that when we deal with algebra, our students still struggle with simple maths such as minus 6 minus 3. What is minus 6 minus 3? How do we reach to minus 9 actually? Minus 6 minus 3. Why do we say it's minus 9? We can look at this minus 6 minus 3 from the, let me draw a line like this one. It should be a straight line, and say 0, and say on the left side of 0, it should be a straight line, guys. It's minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. This side you've got positive numbers. Now, minus 7, minus 8, minus 9. So minus 6 minus 3, I'm saying it's minus 9. So imagine you are here at minus 6. So you move to the left 3 times. Minus actually might be saying move to the left 3 times. So you are at minus 6 and you move to the left 3 times. So it's 1, 2, 3. You are at minus 9. So it's minus 9 a squared b. Be careful. We are dealing with algebra. Don't even think of saying a squared, it becomes a to the exponent 4. No, we are adding like terms. When you add like terms, just say, let me explain it in this way. Let's say you have got minus c, let me say you have 5x squared plus 3x squared. Your focus should be working with these numbers. You just say 5 plus 3, which is 8. So it's going to be 8x squared. You have got x squared, 5 of this x squared. When you add 3 of this x squared, they become 8. So be careful when you add like terms actually. Don't even put your focus on the, what can I call it? The variable and its square. Just put your focus only on numbers. Just say 5 plus 3, it's 8. So it's going to be 8 of those guys. Going to be 8 of x squared. So it's minus 6 minus 3, which is 9. Which, I'm sorry, it's not 9, it's minus 9. Minus 6 minus 3, it's minus 9. So it is minus 9 a squared b. So I was adding this with this. Adding of like terms. Now, the third term and the fifth term, they are also like terms. Hopefully you can see that. The third term and the fifth term, they are like terms. They look alike. If you look at them, they look alike. You have got ab squared. It's minus 2 ab squared plus 9 ab squared. So it's ab squared minus 2 ab squared plus 9 ab squared. So these are the like terms. And we can add and subtract like terms. So what is minus 2 plus 9? You can even press your calculator after all and just say minus 2 plus 9, which is 7. So you're going to have 7 ab squared. Don't worry with these guys here. ab squared ab squared. I said when you add like terms, you put your focus on numbers. So you say minus 2 plus 9, it's 7. So it's 7ab squared. Unfortunately, I'm not writing my figures down, but you don't worry, I will explain it. I will write and still explain it. For now, just know the focus is on adding like terms. And the sixth term does not have a like terms. Does not have a like term. So the solution is like this. 2a cubed minus 9a squared. So let me explain it for the last time, because adding of like terms is very, very important in maths. Okay, so I started with this guy, 2a cube, and I said 2a cube does not have a like term, so it will just be 2a cube. Then I went to minus 6a squared b, and I said it's the like term of minus 3a squared b. So minus 6 minus 3 is minus 9. It actually minus 9a squared b. So these two guys, they give you this one here. Minus 2ab squared plus 9ab squared, they are also like terms. This one and this one, they are also like terms. And what do we do to like terms? We add them. So these two, they give us this one. 3b cube does not have a like term, so it will just be 3b cube. So you are done. You multiply the binomial with a trinomial. That was it. Is you are learning great stuff. Grade 10s, you are learning great stuff. You are learning algebra, which is how do we multiply a binomial and a trinomial. The focus now is on how do we multiply these two guys, a binomial with a trinomial. Worked example number 2. This is a binomial and this is a trinomial. If you look on what I've written here on my example 2, it appears that there is no question. I think my question should be simplify. So when you simplify these two guys here, you are multiplying a binomial and a trinomial. And remember I said you are going to take this guy from the first bracket and multiply the guy with every guy in the second bracket. And you are also going to continue with the same idea. Multiply this guy in the first bracket with every guy, with every term in the second bracket. So once you get the procedure, it should be simple. Multiplying a binomial and a trinomial. Let's continue. You see, I'm saying this 2p, I'm going to multiply it with every term in the second bracket. My first bracket is this one. My second bracket is this one. So that's why I'm saying 2p is going to be multiplied with every guy in the second bracket. Minus 3q is going to be multiplied with every guy in the second bracket. So it should be simple now. Let's do it. We're going to say 2p. We're going to say this. I don't like the color of my highlighter. I don't like the color. Can this be visible? Okay, yes. 2p, I'm going to multiply it with 4p squared. The same 2p, I'm going to multiply it with 6pq. The same 2p, I'm going to multiply it with 9q squared. Remember, the guy outside the bracket, multiply every guy inside the bracket, which is this is called the distributive law of maths. So it's going to be 2p times 4p squared. Let's check. Yes, if we say 2p, if we say 2p times 4p squared, let me raise all these others. Yeah, let me raise this thing so that you can be able to follow with me. If we say 2p times 4p squared, we know that, okay, let me write it here. 2p times 4p squared. 2 times 4, it's 8. P times p squared, it's p cubed. So it's 8p cubed, which is this one here. So you are going to again multiply 2p with 6p cubed. 2p times 6p cubed. 2p times 6p cubed. 2 times 6 is 12. P times p, it's p squared. There is this q here. So it's 12p squared q. Now we're going to multiply 2p with 9p with 2p with 9q squared. So we're going to multiply 2p with 9q squared. We know that 2 times 9, it's 18. So it's 18. Since I'm preferring to start with p, it's going to be what's happening 2p. Oh yeah, it's going to be p q squared. It's going to be 18p q squared, which is this one. Now we go and multiply negative 3q with 4p squared. Let me erase here so that I will be able to show my workings here. This is my area where I show workings. Okay. Showing of workings, it's very important in maths lesson. So I'm multiplying negative 3q with 4p squared. Negative 3 times 4 is negative 12. So it's negative 12 p squared q. I prefer to start with p. If you're thinking of negative 12 qp squared, still right, but it's a matter of preference here. I prefer to start with variable p first. So it's minus 12 p squared q, which is this one. Now you say minus 3q times 6pq minus 3q times 6pq. We know that negative 3 times 6, it is negative 3 times 6 is 18. 6, 12, 18. 18. I prefer to start with p, so this p, I will write this p and write q squared. Q squared comes from q being multiplied with q. So it's minus 18p q squared. I think I'm doing well here. I'm patient with my explanations. Now I'm going to take negative 3q times 9q squared. Negative 3q times 9q squared. Negative 3 times 9 is 27. Minus 27 q times q squared, it's q cube, which is this one. Now from here, after finishing your multiplication, don't forget, this is a very important skill in maths. Immediately after you multiply a binomial with a trinomial, I'm referring to this expression here. Once you get this, do not forget to add your like terms. So let's write neatly and check. I'm going to erase first how many terms we have. We have to check how many terms do we have. How many terms do we have? We have got 1, 2, 3, 4, 5, 6. And guys, you have to add like terms. Not only add, you can also subtract like terms. You just have to check on your expression whether you have to add or you have to subtract. So 8p cube, let's check the first term. Doesn't have a like term here. It does not have a corresponding like term. I don't see p being raised to the power of 3. This is the only term where we have p to the exponent 3. In all these other terms, p here, on the second term, p is raised to 2. On the third term, we have p, only p. On the fourth term is p squared. So the first term is the only one which is being raised to the power of 3. So this one will just be 8p cube. You cannot add it to any guy. You cannot add it to any term. It doesn't have a like term here. So it remains as 8p cube. So which guys are the like terms here? Let's look out carefully for the like terms, which is the second term and the fourth term. Because it is 12p squared q, and the fourth term is minus 12p squared q. So these are the like terms. And it's 12p. What is 12p squared q? Minus 12p squared q. This one, it's easy to know that it's 0. Because if you take a guy and subtract that guy, you get 0, like 6 minus 6. 12p squared q minus 12p squared q, you get 0. Now, which other terms are the like terms? I'm going for the third term and the fifth term. These are the like terms as well. Third term and fifth term. Oh, they will also give us 0 because it's 18pq squared minus 18pq squared. I'm actually left with 2 guys here. I'm left with the first term and the sixth term. So I believe the final answer is going to be 8p cube minus 27q cube. Let's check. Yes. The writer here is a human. So, wait, what's happening here? Where did I even get 2a cube minus 27q cube? 27q cube is right. It is minus, but it's not 2a cube. It's 8p cube. Not even to mention here, I'm making a terrible mistake. Not even to mention that in my expression, we don't even have a. Maybe there was a typo. It should be, I'm left with these 2 guys. I'm left with 8p cube with minus 27q cube. Remember, the second term and the fourth term, they gave us 0. This guys and this guy, they are no more. This guy and this guy, they are no more. We are left with 8p cube minus 27q q cube. Okay, we are humans. Humans makes mistake, but hopefully you get the ideas here. Now, I believe you guys, you know how to multiply a binomial with a trinomial. And we have learned very important skills when we are multiplying a binomial and a trinomial. We have learned the idea of a distributive law. You are going to meet this idea of distributive law more often in maths. So let me say you have something like x. In the bracket, you have got x squared plus xy plus 3x plus 4. Close the bracket. Actually, I wrote many terms inside the brackets intentionally. Why? I just want to emphasize on the distributive law to say to you the number outside the bracket should multiply every term inside the bracket. So it's going to be x times x squared, which is x cubed, x times xy, which is x squared y, x squared times 3x, which is 3x cubed, x squared times 4, which is 4x squared. So we have learned a very important skill in algebra, which is called the distributive law. Another skill that we have learned when we were working with this multiplication of a binomial and a trinomial is it's a adding and subtracting of like terms. You have to remember that in maths you can only add and subtract like terms. What actually are the like terms? Maybe I should also explain. What are the like terms? Let me give you this expression. I'm going to first erase everything here. I want to explain what are the like terms. I know it's easy to spot the like terms actually, but I just want to explain what are these like terms, or how do we see like terms. Let me say you have an expression which is 2x squared plus 3x. These two terms, 2x squared and 3x, they are not like terms. Why? Yes, these two terms, they have the same variable, which is x. Like terms should have the same variable. Yes, in these ones, they do have the same variable, but they are not like terms. Why? Because the exponents are not the same. For two terms to be considered to be like terms, the variables must be the same. The exponent also must be the same. So if I change this expression 2x squared plus 3x and write 2x squared plus 3x squared. Yep, these two, they are the like terms. Why? They have the same variable x. Same variable x, same exponent, which is 2. So what do? We add. We can add these two. I'm not saying like terms should always be added. Don't get me wrong. You have to check the operation. You have to check the sign here. So the sign says add. So you add your like terms. It becomes 5x squared. Let's say you had something like 3x squared minus 2x squared. Yes, these two, they are still like terms. But this time we're not going to add because the operation says subtract. So you subtract 3x squared minus 2x squared, which is x squared. It is 1x squared. Sorry, I'm not going to write the coefficient 1. I'm just going to say it's x squared. Wow. Hopefully, you are getting important skills of algebra. I think I need to get water. I'm going to stop my recording, get water, and then we'll continue with our interesting maths lessons where we are looking at skills of algebra for grade 10 student. Remember guys, your grade 10, it is very, very important. This is where you build your maths, you sharpen your mathematical skill from grade 10. When they ask me, how did I become good in maths? I say, oh, look back in grade 10. This is where everything started. The work that I have put in grade 10, the skills that I have acquired in grade 10 were the most important skill. To me, grade 10 is the most important grade in the secondary schools, in the high schools. Thank you guys. Hopefully you are enjoying our lessons. For now, I'm going to end the show and end this meeting. I'm going to see you next time. We will continue together.